going to talk about solving equations with variables on both sides of the equation. First, our vocabulary and our rules. When solving equations with variables on both sides, we want to collect variable terms on one side. 2, collect constant terms on the other side. And 3, use inverse operations to solve. Remember the identity and equation that is true for all values of the variable. And the equation has no solution when an equation that has no solution. And we'll talk about some examples like that. And just keep in mind the golden rule of algebra says do unto one side of the equation what you do to the other. Example 1. Solve an equation of variables on both sides. So let's just first rewrite it. So we have 7 minus 8x equals 4x minus 17. Our first goal is to get our x's on one side. So let's start with adding 8x. Add 8x. This 8x is going to cancel, and we're going to be left with 7 equals 12x minus 17. Next, we're going to collect our numbers on the other side, so plus 17, plus 17. We're left with 24 equals 12x. And our last step, we're going to divide everything by 12. Divide by 12. And x equals 2. If we plug 2 into our original equation, let's just do that in silver. 7 minus 8 parentheses 2 equals 4 parentheses 2 minus 17. 7 minus 8 times 2 is 16. 4 times 2 is 8 minus 17. 7 minus 16 will give me negative 9, and 8 minus 17 will also be negative 9. So we worked it out correctly. Our correct answer is x equals 2, and we are done. Solve an equation with grouping symbols. We're asked to solve 9x minus 5 equals 1/4 parentheses 16x plus 60. So first thing we're going to do is we're just going to rewrite the original equation. So that'd be 9x minus 5 equals 1/4 16x plus 60. Next thing we're going to do is we're going to distribute. So 1/4 times 16 is going to be 4x plus 1/4 times 60 is going to be 15. And just write down the right side again. 9x minus 5. Next thing we're going to do, we're going to start moving our numbers. So we're going to subtract 4x from both sides. Subtract 4x, and we'll just move the 5 as well. We're going to add the 5, add the 5. So 9x minus 4x is going to be 5x equals 15 plus 5 is going to give me 20. And last step, we just divide by 5, divide by 5, and x equals 4. Now, if we want to check and see if our work's correct, we just plug in 4. So we have 9 parentheses 4 minus 5 equals 1/4 parentheses 16 parentheses 4 plus 60. 9 times 4 is 36 minus 5. And just copy down to 1/4. 16 times 4 will be 64 plus 60. 36 minus 5 is 31 equals 1/4. 64 plus 60 is 124. And 1/4 of 124 is 31. So our correct answer is x equals 4. And we are done solving example 2. Solve a real-world problem. This one's about car sales. A car dealership sold 78 new cars and 67 used cars this year. The number of new cars sold by the dealership has been increasing by 6 cars each year. The number of used cars sold by the dealership has been decreasing by 4 cars each year. If these trends continue, in how many years will the number of new cars be twice the number of used cars sold? So let's first write our expression. Let's do this ocean. So it's going to be 78. That's for our new cars. And increasing by 6 cars each year. So that's going to be plus 6x. And let's pick another. Let's use this galaxy. And the used cars, there's 67 used cars this year, and has been decreasing by 4 cars each year. So it's going to be 67 minus 4x. And the other clue it tells us, it's asking us, in how many years will the number of new cars be sold be twice the number of used cars sold? So we have to multiply the used cars by 2. So this side is my new, this side is my used. So first thing I want to do is just rewrite this left side, and I want to distribute the 2 to the right side. So 2 times 67 should be 134, and 2 times negative 4x will be 8x. Now we're going to add 8x to both sides to cancel the 8x out. And simultaneously, we're just going to subtract 78 from both sides. So my 78 cancels, and my 8x cancels. So we're left with 6x plus 8x is going to be 14x equals 134 minus 78 is going to be 56. And then last step, just divide everything by 14. We get x equals 4. And if we want to double check, we just plug back into our original equation. That's going to be 78 plus 6 parentheses 4 equals 2 parentheses 67 minus 4 parentheses 4. 78 plus 6 times 4 is 24 equals 2 parentheses 67 minus 16. 67 minus 16 is, we'll just continue up here. 67 minus 16 would be 51. So 2 times 51. And 78 plus 24 is 102. 2 times 51 is 102, so it checks out, and x equals 4 is our correct answer, and we're done. Example 4. Identify the number of solutions of an equation. We're going to solve the equation, each equation if possible. So first thing we're going to do is just rewrite the equation. So we have 3x equals 3 parentheses x plus 4. Next thing we're going to do, distribute on the right. So 3 times 3x is 3x plus 3 times 4 is 12 equals 3x. Subtract 3x from both sides. This 3x cancels, and we're left with 0 equals 12. And it's not possible for 0 to be equal to 12. So in this equation, there's no solution. Next example. We have 2x plus 10 equals 2x plus 5. So we have 2x plus 10 equals 2 parentheses x plus 5. Distribute on the right side, and we have 2x plus 10 equals 2 times x, which is 2x, plus 2 times 5, which is 10. They appear to be the same equation. Let's see what happens when we try to solve this. So subtract 2x, subtract 2x, subtract 10, subtract 10, and we end up with 0 equals 0. And this is true. Take note the last statement was false. So in this situation, we said we can say all real numbers are solutions. Or in our vocabulary, sometimes this is called the equations of identity. So we can call this an identity equation. And we are done example 4. Hopefully this helps you understand how to solve equations when variables are on both sides of the equal sign. See you in the next video when we talk about writing ratios and proportions.